All right, let's dive into one of the most fundamental ideas in all of programming, variables and scope. We're going to find out how the apps you use every single day actually remember anything at all.
I mean, think about it. You go to a website, you type your name into a box, you hit a button, and the next screen says, "Hey, welcome back." How did it know your name? That's not magic. That's a core concept called a variable doing its job.
So what is a variable? The easiest way to think about it is like a labeled box, a little memory box for your code. You can put information in the box, you can look at what's inside, and you can swap it out for something else later. And because it has a name, you always know exactly which box you're dealing with.
Okay, let's get a bit more technical. A variable is just a reserved spot in the computer's memory, its RAM. And it has three key parts: a name, so we can find it; a data type, which tells the computer what kind of stuff it's allowed to hold, like text or numbers or dates; and most importantly, the value inside it can change while the program is running. So how do we actually make one of these memory boxes in our code? Well, in VB.NET, the magic word is dim. You just say dim, then the name you want to give your variable, as, and then you tell it the data type. So dim fname as string creates a new box called fname that's ready to hold some text. Simple as that. Creating variables seems pretty straightforward, right? But this is where things can get a little weird. What happens when your program suddenly gets a case of amnesia? Let's walk through a classic example of this exact problem. Okay, so check this out. Imagine we have an app with two buttons. For button number 1, we write some code. We create a variable called radius, we grab a value from a text box, do a little math, we click the button, and it works. Perfect, no problems at all. But then we move over to our second button. We try to use that exact same radius variable and bam! The program breaks. We get a big ugly error that says name radius is not declared. Wait a second. What? We just declared it. We saw it work. So why is the program now acting like it's never even heard of this variable? This little mystery gets to the heart of one of the most important concepts you'll ever learn in programming.
The solution to our problem has a name. It's called scope. And really, scope is all about location, location, location. It defines where in your program a variable is actually alive and accessible. Think of it as the variable's home turf.
So here's what was going on. When we declared radius inside the code for button 1, we gave it something called procedure scope. That means it was born there, it lives there, and it dies there. The code for button 2 is a completely different procedure, so it can't even see it. The fix is to give it class scope. By declaring the variable at the top level of our form, the class, we make it visible to every single procedure inside that form. It's a way of keeping things tidy and preventing one part of your code from accidentally messing with another. And here's what that fix looks like. Notice where the dim radius line is now? We just moved it. We took it out of button 1 and put it right up at the top of the class. By doing that, we've promoted it. It's now a class-level variable and everybody can see it.
And the result? Just like that. Both buttons work perfectly. They can both access and use that same shared radius variable. Problem solved. That's the power of scope.
So understanding where to declare your variables is a huge deal. Now that we've got that sorted, let's see how all these ideas come together to build something practical, like a user registration form.
You know, before a good programmer writes a single line of code, they make a plan. For a registration form, we'd map out what we need to remember. Okay, we need the user's name, that's text, so we'll use a string. A birth date, yep, there's a date type. Gender, we can use a Boolean for that, true or false. Number of family members, that's a whole number, so an integer is perfect. This right here is our blueprint.
And with our plan ready, we just translate it straight into code. Look, we're just using dim to create a variable for each piece of information we planned for, matching the data types. Our empty memory boxes are now all set up and waiting to be filled. Which brings us to the final piece of this puzzle, assignment. See, declaring a variable is like setting up an empty box. An assignment statement is the action of actually putting something inside that box.
The official term is an assignment statement, and it uses the equal sign. Now, this is super, super important. In programming, the equal sign does not mean is equal to, like in math class. You should think of it as an arrow pointing to the left. It means take the value on the right and store it in the variable on the left. It's a one-way command.
Let's look at a real example. This line here says UName equals textbox1.text. Here's what that's telling the computer. Go find that control on the screen named textbox1, get the text property out of it, and then assign that value to my u_name variable. The data flows from right to left.
And what's really powerful is what you can put on the right side of that equal sign. It can be a direct value, like the number 5. It can be the value from another variable. It can be the result of a math problem, or, like we just saw, a value you grab directly from the user interface. It's incredibly flexible.
So, to wrap this up, there are 2 golden rules of assignment you always have to remember. First, the variable, the memory box you're filling up, always goes on the left side of the equal sign. And second, you can't put a square peg in a round hole. The data you're storing has to match the variable's data type. You can't stuff the word hello into a variable that's expecting a number.
And here it is, the final result. We declared our variables with the right scope. We used assignment statements to capture the user's input, and now our program successfully remembers that information and can display it back. We've brought all the concepts together into a working app.
So, we've gone from creating a simple memory box to solving those tricky scope problems, all the way to building a functional form. You now have the absolute core tools to make software remember things. So, the only question left is, what will you build with it?